Hey, good afternoon or good evening or good morning, wherever you are in the world. Very warm welcome to Open Clock Club. Today I am on my own. We've got no Open Clock Club team. So I'm running the kind of letting people into from the waiting room and all that stuff. So more distracted than even normal. So very warm welcome, particularly to beginners and new people here. Just keep admitting people as I go along. Open Clock Club. This is a free to attend, open to all social community event that happens to be loosely based around repairing pendulum clocks. And that came about because of a book that we wrote a couple of years ago called How to Repair Pendulum Clocks. And that was about getting people started in clock repair, whether that's for the well-being benefits, the social element like this, or whether you're going to actually take up clock repairing as a hobby or even as a profession. So warm welcome. Please remember that these sessions are recorded and they go on our YouTube channel archive. So if you wish to remain anonymous, then... All right, Andrew's put his hand up.
No, sorry, that's a mistake.
All right, okay. So if you wish to remain anonymous, then please keep your camera turned off. Okay, so I see you're talking amongst yourselves. That's brilliant. The live chat here really helps us out because the events tend to be a bit sort of crazy. We never know quite what's going to happen. So it's great for us to be able to go back through the chat, and that means we can base future events on it. That's where we get our ideas from as well. So please keep going with the live chat. I can kind of see it out of the corner of my eye, but I'm afraid I won't be able to do much about it. Okay, so over these months we've been running these events. We've covered camera's got a bit of a mind of its own in terms of focusing. I see we've covered a whole range of things, but primarily these events are to encourage beginners to get started. People come and they go. It's kind of quite interesting that the numbers of attendees for these events seems to stay the same, but there are always new people. So people obviously disappear off somewhere else, which is brilliant. And I hope they join other groups and fora and so on and develop their practice. Anyway, so a few weeks ago, somebody asked, I think it was Devashish, about mainsprings for Fusee clocks. And I realized that a Fusee clock, that's a clock like this, where we have a mainspring inside this barrel, but we've also got this conical gear here called the Fusee. And these are often, but not always, English-made clocks. Fusee clocks have been made all over the place from the, oh gosh, well, Leonardo da Vinci was talking about Fusees. So ever since clocks are made, the concept of a Fusee has been around basically for portable clocks that are spring driven. And what the Fusee does, the cone, is it evens out the power delivery from the mainspring. So in theory, at least, although I think in reality it's rather different. Great to see you all there, and great to see you all saying hello, by the way, on the live chat. The principle is that when you make a clock or make a watch, it's probably more important, with something like a verge escapement or an anchor recoil escapement, you've got a thing called a positive escapement error. So what positive escapement error does is it means that the more power, the more you put your foot on the gas, the faster the clock runs and vice versa. So you want even power or even torque coming from your mainspring throughout the duration of running in the clock. And of course, you don't get that with a spring, not this coiled up type anyway. You get a relatively large amount of torque at the beginning of the week, in the case of a week running clock, and that reduces and reduces and reduces. So your clock slows down. And so the mainspring in here and the profile of the fusee are meant to be matched. Now, a clock like this, which is a kind of mass-produced, a good quality clock, I don't think that is the case. In watchmaking, there is a bar that people, I think Derek's having trouble finding us. There's a bar that you fit to the fusee arbor with a sliding weight. So you can balance making the fusee to match a spring. It's probably easier to do it that way around rather than it is to try and find a spring to match a fusee. However, when we get a clock like this, and we're going to take this mainspring out in a short while, we hope that it has its original spring, or we hope that if somebody's had to replace the spring because the spring broke in the middle, for instance, that they've matched it to the fusee. But of course, that is quite tricky. One of my students a couple of years ago, maybe 5 years ago now, he did some work on matching fusees to springs. And remember, with a clock like this is just a timepiece clock, so it has hands, it doesn't have any striking work. It doesn't have a great deal of work to do. So if you get to the position where you have to replace a spring because the spring breaks, for instance, you don't want to repair it in the middle, although that can be done, it's an option, then you really want to, I think everybody would agree, I hope they would agree, that you want the clock to run on the minimum power possible, typically for it to be reliable. And that is because you don't want the clock to be overdriven. So let's say there's a value, and we'll call that value X. We want to build in maybe 10 or 15% safety margin, but we don't want the clock to be running on 2X or 3X or something. And I think what happens with these clocks is they get incredibly overdriven. So a bit of a rant here, but the reason it's really tricky to find a spring to match a fusee clock is because of the cube law of the thickness of the spring. I'll just arm myself with a bit of paper. Read the printer, as everybody does, everybody does. So if we've got our mainspring, and it looks something like that. This is the kind of width of it. Let's make it into a clock mainspring even. Something like that. Ooh, maybe like that even. Anyway, we've got a mainspring. Okay, it's dead easy to get the right width because the width is determined by the height of the barrel here, less a bit, I don't know, you just need clearance there. So 0.5 millimeter, maybe 1 millimeter or something like that. So let's do a bit of color coding. We'll love a bit of color coding. So this value is no problem. The height, what watch people call the height of the spring or the width of the spring. The difficulty is in, and the length of the spring isn't a problem either. We know as a rule of thumb, and I would always say don't build your practice on rules of thumb, but let's just do a little drawing here. We're looking in plan at the barrel. Here's the barrel arbor. Here's the setup fusee setup square. Typically, when the springs unround, as a rule of thumb, the spring wants to occupy about 1/3 of this value. So 1/3 of the value between the barrel arbor and the inside barrel wall in terms of length. That's only a rule of thumb. That really doesn't matter. Just buy a long spring and cut the end off it until you're happy with its length is a kind of simple way to approach that. The problem, the challenge is in the thickness of the spring, or what the watch people call the strength of the spring. And the reason that's difficult is because the strength of the spring is proportional to the width. Okay, so my physics isn't that amazing, but if we half this value, we have a spring that's half as high, half as wide. We've got half the strength of the spring. However, that doesn't apply to the thickness of the spring. the strength of the spring is proportional to the cube of the thickness. So if you've got a good math brain or a calculator at hand, just take any value that you might find for a mainspring. Let's say 0.35 of a millimeter or 0.4 of a millimeter, typical mainspring value. And it doesn't matter whether you call it 0.4 or 40 or 400, who cares? Cube that value and then get a very similar looking value like 0.38 or 0.42 or 0.45 and cube that value. And you'll see there's actually a massive difference in strength of the spring with what seems like a little bit of difference in thickness of the spring. So there's our first challenge, but I don't think that's the biggest challenge at all because we can kind of work around that. I think the biggest challenge is that the material or the metallurgy of mainsprings, of spring steel or steel overall, has changed massively over the centuries that we've been making Fusee clocks. So let's say the first Fusee clocks around in the 16th century. I don't know my horological history that much, but balance controlled ones. Lots of industrial processes were improved in the 17th, 18th, 19th, and 20th centuries. So we've probably got 3 or 4 pretty significant step changes in the way steel was made and hardened and tempered and all that. So the reality is, if you take a spring like this, let's say this is this clock, let's say it was made in 1850, 1950, let's say it's 150 years old, and you go to your material supplier and say, I want a spring that's X wide, that's not a massive problem. But this spring, well, we'll see because we're going to get it out in a bit. But let's say it's 0.32 or 0.38, and they say, we haven't got one of those, but we've got one that's 0.4. We now know that because of the cube law of the strength of a spring, that's going to cause us a problem. And we're going to get a double whammy because we also know that the material that they're going to send, the spring they're going to send, might be a really great spring, but it's highly unlikely to be matched to this Fusee. And I bet you a pound to a penny, then if you've got that expression in the States, that clock is going to be overdriven. I see so many where it's sensationalizing it, but the clock's kind of been torn apart and spend a lot of time taking modern springs out and replacing them with thinner springs or even narrower springs. And the problem is, how do you decide what you need? Well, my student did some really good work. He bought a torque screwdriver, a digital torque screwdriver. It was about $50, and it was about $50, and he put it on the Fusee arbor, and he figured out what the torque of the spring was by trying it in different positions as the clock unwound. He then made a pulley and fitted it on here and ran the clock from weights, adjustable weights. And he basically looked at the difference between what the clock actually needs to run on and what the spring was outputting. So you could go down that route, and it's a big sort of undertaking. But actually, for a lot of clocks, historic work, it's well worth spending the time doing that in order to find a spring. But there's many, many difficulties here because the range of size of springs that is offered is tiny. You just can't seem to find the right thickness of spring for relatively wide springs like this. So I've got an option. It's not a solution, and it might not suit everybody, but just an idea. Okay, so there we are. Got that off my chest. So let's get this clock apart and see what size the spring is. Okay, so last week, just to recap for people who weren't here, on a clock like this, normally on a what we call a going barrel clock, so like a Smith's Enfield clock, regular clock, you've got one winding square here where you put the key and you wind the clock up. Now you can see on this clock, you've actually got 2 squares. This one is not a winding square. This is pre-loading for the mainspring. And we went through how you kind of try and determine what the preloading might be last week. So we've let, as you can see here, all the tension off the spring, really important. So let's get that pin out, and we need to get this mainspring setup ratchet wheel off. I'm probably just going to tap it out with a bit of brass, I think. There are many ways to deal with this. You could use slotted pliers. I'm going to use my file cleaner. I just tap it out like that. So, and off it comes. Quite interesting these, because they're straight from the casting, very little finishing. You can just see there, look, some of the original sort of casting marks. So that's that. Let's arm ourselves with a bit of card. I'll just cut up my photographic background, pop that under there just to protect it. And I'm going to use the same thing, bit of brass, just to tap out the pin. Like this, easy peasy. Not quite sure why I'm doing it like this week. Some weeks it's, I would try my slotted pliers to get them out, but this seems reasonable. If I ever get around to doing my files video, by the way, that I've been doing for months and months and months, then this badger is the file cleaner. It's basically a bit of brass. I'm not going to go off, not this thing, which is not a file cleaner, it's a file destroyer. Anyway, I'll talk about that later. Distracting from actually taking this clock apart. So lovely distractions in clockmaking. All right, this one's a little bit more tricky because the Fusee, talked about this a little bit last week, but let's have a zoom in and have a closer look. Let's just see if we can. Oh, my camera's decided it doesn't want to change its exposure. Okay, so what we've got inside here is the Fusee stop iron. Let's focus a bit. Yep. Okay, so we know that the mainspring on this clock is pre-loaded by that ratchet wheel that we just took off there. And the point of this is that you want to use the useful bit of the center of the spring. You don't want to use the bit when it's fully wound, really tight in the barrel, and you don't want to use the bit when it's nearly fully unwound. You just want to cut out the bit from the middle. It's called stop work. You find it on carriage clocks, some continental work, all different kinds. Many of you will have heard of Geneva stop work. Well, this is a different kind. Let's just admit, people. Sorry if you've been waiting in the waiting room. We don't have Team Open Clock Club this week. So this is the top end of the stop work. We just rotate the Fusee a little bit. You can see there, get my pointy stick. You can see, pointy stick here, look, on the end of the Fusee, there's a sticky out bit of metal called the Fusey Horn or the Fusey stop piece. There's another bit of metal here, which is sprung, called the Fusey stop iron. See the spring for it here. And when the clock's fully wound, the line moves across, or the chain, and it pushes the stop iron into the path of the stop piece here, and it limits the amount that the clock can be wound. So unlike a regular kind of spring-driven clock that you might be familiar with, when you're winding a Fusee clock, it comes to like, it's kind of quite unusual because if the spring is matched to the Fusee, when you wind, it doesn't feel that it's getting any harder to wind. You can't sort of perceive the spring getting stronger, not getting stronger, but anyway, more wound. And then it comes to a stop all of a sudden. So kind of quite an interesting experience. Anyway, let's just see if we can get the, I'd like to leave that in place so you can see it. There we are. So the pins weren't very tight. So double, triple check in our mind that all the power is off the spring, which of course it is, because we've got that winding ratchet off there, the mainspring ratchet, sorry. And let's just lift off the plate. Here in this corner. There we go. And we reveal our really rather straightforward train. But let's just pop that to one side for a second. Always be careful when you take the plate off a clock like this. Don't leave it hanging around on the bench with the mobile sticking up like that, because it's so easy just to lean across and for your sleeve or something to touch the arbors and bend or break the pivots. So if you take the plate off and leave it, then always take the mobiles out, once you've photographed it, of course, and lay them down so the pivots don't get broken. Okay, so let's just have a little look at this for people who've not seen this arrangement before. So here's our Fusee stop iron. So there are three kind of four, let's call it four, four sort of elements to this. One is the bit here where the spring keeps it out of the path of the stop piece that's on the front of the cone, screwed onto the plate, quite straightforward. One is the pivot point here. These are often marked across by the maker. You can see there's a saw mark there. So if you've got a striking clock or a three-train clock, one will have one strike across, one will have two, and one will have three. So you can't get it mixed up. So the Fusee stop piece normally rotates here in this plane. Just move it around in this plane. But the chain or the line in this case works its way up the Fusee and off the barrel. And when it gets to the small radius, it pushes the stop iron across, and then the stop piece engages. You can see this is cut, this is undercut here. So you get that absolute engagement. It can't slip out. On older clocks, these are less substantial typically, and it's you often see them bent or soldered and stuff like that. Don't think there's a whole lot else to see here, all pretty straightforward. Fair. So our train, quite standard sort of stuff. Let me get a pair of tweezers. Nice brass tweezers. Well, I really like these relatively inexpensive bendy things. So let's get the train out and work our way down and just make any notes as we do so. So normally you'd photograph the whole thing, particularly if this is your first time. We had on our Facebook group, and major thank you to those people who contribute regularly to the Facebook group. It's really appreciated. It's been a busy week for me. So to know that it's in safe hands is fantastic. One thing I did this week was I made up some, I'll hold them up so you can see them, photographic scales, which you cut out with your scissors, and you use them to record information for like a name of owner or reference number of the clock and the date you worked on it. So you put those in your picture. So I did this, I'd seen these all over the world and did it about 15 years ago. They get spread around, which is really good. So I put them on my website. It's free to download if you want to download, print some and share them. But anyway, so you do your photographs here. Let's just see if we can encourage our camera to actually focus. And let's lift out the escape wheel. Pretty straightforward. Interesting, it's dot marked. Don't quite know why that is. Maybe it's some part of the finishing process for batch production. These clocks were made in batches, not mass production per se. Pretty straightforward, what we call Victorian, so mid-19th century production, relatively parallel arbors and quite a long pinion. The earlier clocks tend to have shorter pinions and more tapered arbors. Crossings quite heavy, quite a heavy sort of mobile. These things are pretty much sort of industrial manufacture, but in good condition, no worries about that. Here's our upper intermediate wheel. Some people call it the third wheel. And same applies here. We've got some pinion wear, I'm not particularly fussed about that. And we might have, we've got, that's going to be actually really interesting. I'll take a closer photograph and put it on Facebook. But we've got what I think a lot of people would call significant pivot wear. I'll put this on Facebook later, take a photograph with the macro lens. So it's worn down to about, I don't know, 2/3 its diameter. It's got kind of a mushroomy bit on the end. You can't really see it there, but I say I'll photograph it. So a pivot that's worn, you know, what do you do with something like that? I think I'll probably leave it. It's not going to break. It's got, you know, when the clock's clean, the reason it's worn so badly, inverted commas, quote unquote, is because the clock's been running when it's been dirty. I think if it's cleaned and regularly serviced, of course, we don't know it's going to be cleaned or regularly serviced. All right. No giving into the weather. Zero giving into the weather on the corduroy jacket front. Never. No, not allowed. Anyway, or shorts wearing either. So that ain't gonna happen. So a lot of people would go, "Ooh, that's got to be something." Like polishing this out, which isn't polishing it, of course, it's filing it smaller. It's just going to make the whole thing weaker and more worn. So that's totally out for me. So the question is, do you cut it off and replace it, or do you just leave it as it is? There is an issue there, of course, because the pivot's worn and the pivot hole will inevitably worn as well. Then we've got to check depthing. And if the depthing is out, then that's a different question, because do we bush, rebush, do we bush or rebush, or to move the depthing to a more optimal position, or do we repivot as part of that process? But that's the fun of Open Clock Club. We can look at that. The other one's just got a little bit of wear in it. So I'll pop that picture on Facebook. Right, okay, here's our center wheel. Nothing much to report there. Yeah, funnily, unlike long case clocks or tall case clocks, the center wheel back pivot here is in good condition. It's a little bit scarred, but it's fine. The clock just needs washing and it'll be good to go. Okay, so that's our train, pretty straightforward. If you were starting, I would strongly advise that every clock you do a train count. So that's count the number of teeth on the wheels and the number of leaves on pinions. It's great for two reasons, at least two reasons. One is that if you ever get a clock in future with missing wheels or wheels that you think have been changed, my room is not air conditioned. We don't have aircon in the UK as such, you know, not in domestic properties anyway. No aircon here. It's a cool, I don't know how hot it is. It's about 30 or something. I'll go get the thermometer in a bit. No, air conditioning. This is Yorkshire. So train counts really useful. They help you if you get a clock in future, but also when you get into clockmaking on the Facebook group, again, we've had lots of people who've bought clocks. In fact, we've got one at the moment. I won't get it down because that's another distraction, but I did put a picture of it there with no pendulum and no motion work. So it's really useful to have a whole set of train counts, and it only takes about 5 minutes. So another thing to do, note to self, I'll put that up on the website too, on the downloads page. It's just an Excel, you can make one yourself, but it's quite a nice one because it's got all the pivot sizes and things. So my advice, do a train count. The other thing about doing a train count is it kind of really engages you with the clock. It makes you look at it. Okay, so onto the meat, if you like, of the animal. You can see here that the fusee, the cone, and the barrel are connected. Okay, so this is the drive between the barrel, the mainspring barrel, and the fusee and the rest of the train. The fusee, great wheel, engages with the center wheel pinion. Okay, in this case, the fusee and the barrel are connected with a wire rope, a galvanized wire rope. Sometimes you see phosphor bronze. Who cares? Cut it off and chuck it away. and don't use wire rope on Fusee clocks. And there's a really good reason for that. It's not just me being awkward as always. That is because a wire rope is not meant to bend around small radii. I'm not an engineer, so if there's anybody out there who is an engineer, I'd love to hear. There's a rule of thumb again, it's something like 20 times the radius of the wire, because the wire work hardens and breaks, particularly with phosphor bronze. I think people use phosphor bronze because I think it's softer, it still marks the brass, so just don't use wire rope. And I was delighted when I looked inside this clock. I bought this from the internet. Look, there we are. Normally, when the clock runs, the run down state is like this, okay? But normally when the clock runs, it doesn't actually stop. It's an 8-day clock and it runs for 7 days. And what's your website address? It's clockmaker-conservator, and there's a page called downloads. So normally the line doesn't have to bend round 90 degrees here. But in the old days, when people used to go on holiday or travel for business, typically those clocks that were owned by people that were often away, the line would break. And I realized it's because the line is often bending through 90 degrees like this. A wire rope is not designed to bend like that. And you can see here, it has broken. It started to break, which of course can be catastrophic again, in sort of scare quotes, because yeah, it's easy to say the disaster. This isn't a disaster, it's just a broken line. Anyway, but on a phosphor bronze line in particular, at this radius here at the small end of the cone, the line can also work harden and fray. So anyway, don't use metal lines on this type of clock. I think there are some late 19th century, early 20th century domestic clocks, like those really heavy. Oh, Devashish is an engineer, and Devashish can tell us about the rule of thumb between the radius of the line and the radius of the pulley around which it runs. Let's get this cut off. We can get the spring out, it's past, and then I'll show you what to use instead of the line. There are some of those kind of quite monumentally built 3-train clocks by Elliott and people like that had wire rope from new. I presume those barrels, these are tall case clocks, are big enough for the job, so they were designed for wire and should have wire. But regular long case clocks and these clocks just put a gut line on there. Now, of course, you could use a synthetic material. On some clocks, like regulators, I've used Dyneema, which I think is a multi-strand polyester. And the beauty of using synthetic line, of course, is you get a bit of paper with it that tells you what its working load is, when you don't get that with the inside of a cow. However, I buy my gut line from Bow brand, and touch wood, I've never had any problems with it. I've just seen a problem with our clock though. Look, somebody has bent over the Fusee stop piece, or the horn of the Fusee, which is a problem because it's a casting, and I think it'll probably break off if we try and bend it back. So why has somebody done that? I mean, we don't want to spend too much time conjecturing. I do only have 2 jackets. Sorry, I'm trying to keep up with the live chat. I've got 3 jackets, a light brown one, a mid brown one, and a blue one. There used to be an expression called, what was it? You didn't wear brown in town or something, but those days are long gone. Some people even go to London and they don't wear a tie anymore. Crazy. I'm sure Sam always wears a tie when he goes up to London. Right, okay. To his club. Just, cut that. So yeah, why have they bent over this piece at the end? 2 reasons, I think. One is because they didn't, maybe 3 reasons, maybe multiple reasons. They didn't know about the relationship between the setup and the amount of line that needs to go on the Fusee cone. So then we put a lot of setup on and then realized the spring was tight inside the barrel before it was fully wound. So rather than changing that, they bent this across. Maybe the mainspring's been shortened, maybe the mainspring's short and it won't again fill up the cone. So who knows? We may never know. Somebody's hammered it round. Don't know. What do we do about that? Do we just leave it? Come on, brains. This is an 8-day clock, and I think there are 16 turns of the Fusee. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 turns of the Fusee. So 8 days, half a turn a day. Sorry, half a turn in 12 hours, 2 turns in 24 hours. Is that right? Yeah. So we've got 1 full turn less. So we've got a 7-day clock, which is no good because you've either got to wind it like a little bit earlier every week. So it's not happening. What are we going to do there? If this breaks off, what you can do is turn a recess in here in a lathe and fit a completely new piece. It's really difficult to actually join a new piece on. Often on things like marine chronometers and regulators, that kind of high quality work, this is a separate piece of hardened and tempered steel, and it's actually screwed or pinned on to the nose of the cone, but here it's all part of the casting. Well, let's just get this apart, have a look inside and talk about the line. I don't want to run over and not get the spring out of the barrel, of course. So it's always slightly scary doing these things, having just bought this movement from the internet, never seen it before. All sorts of things could be problematic. Oh, and there's a problem. She's problem. Okay. The screw thread is stripped. So we're unscrewing it, but it isn't going anywhere. I don't know whether I'll be able to get that out. Probably not. Let's just have a little look. Right, I'm going to try with my Savoy tweezers. I think they're called that. These badgers, they're incredibly useful for this kind of thing. They're balance spring tweezers for cutting really fine wire and things. But of course, you can see they're ground flush. So they're really useful for getting hold of something like that. I'm going to have to look through my eyeglass, I'm afraid. Yeah, that appears to be getting it. You can see these are incredibly useful. Best thing to do if you know a watchmaker is to borrow them from a watchmaker, but just don't tell them that you're going to be putting them anywhere near a clock. These, yeah, Savoy is the name. I don't know whether that's the brand or the design. Maybe it's the brand. I'm sure some watch person annealing it first. When Derek says anneal it first, you mean the brass, Derek? Or the screw? Yes, the brass. Yeah, I mean, that you could certainly normalize it. With brasses, you can stress, of course, we don't want to anneal it fully because it won't do its job. It might be too soft. Although saying that, good point, Reed and Derek. Of course, the thing is soft in the first place because it's a casting. So, yeah. So, yeah, you could anneal it. There's a temperature, if you've got a kiln, called the normalizing temperature, which reduces stress within the material. This is coming out, albeit slowly. So it's either the wrong screw. I wonder whether that is the screw. Yeah, see, that screw's long. We talked about this at live stream, didn't we, on Thursday, that typically in clocks like this anyway, the screw is just the kind of right length for the plate. if it sticks through and it hasn't got a point on it, then that's a little bit of a warning sign. So I wonder whether these screws have been mixed up. Right, I'm making a bit of a mess of this, so not good. Brutal. Yeah, I wonder whether that is the case. And these two screws, because not only, yeah, there we are, it's out. Sorry, I didn't do a very sympathetic job of that. I've got a feeling that that screw is the wrong one, and I bet that stop iron screw is the right one, because it was neither threaded in nor a good fit. So anyway, so it's slip washer, like a great wheel on a thingy clock. Savoy seems bankrupt, can't buy new ones. Oh gosh, what's that name? That brand, ASCO, ASCO, make or Dumont, they make those balance spring tweezers. I suppose a really good pair of flush cutters would do the same job as well. So let's push off the slip washer. Beginners, if there are any beginners out there, then please don't be too put off by all this stuff. Let us know what you want to see in the live stream in future weeks, I mean. But a Fusee clock could be kind of 3 or 4 clocks down the line from your first clock. So I think Jane, I don't know whether Jane's there this week, but she worked on a Fusee clock pretty early in her career. So this, look, wobbly great wheel, really good. That's nice. The great wheel doesn't wobble about like this when the clock's running. The force is in this direction, not in axially, radially, not axially, or tangentially even. So what you don't want to do is to tighten that washer by doming it to make this a really good fit. And there's a reason for that, of course. That's because when you wind the clock, if that washer's too tight, then there's friction there. And what happens is the whole train gets pushed backwards. Oil sticking this thing together. There we are. So the slip washer is off. So don't tighten this washer. It needs to be safe, obviously, but it doesn't need to push the great wheel against the face of the cone. So when we take it off, we can see in here, absolutely right, but quite sort of random, no, random's not the right word, is it? Quite counterintuitive that there's a brass spring, nothing wrong with brass springs, we like those, but also a brass, is it brass? The click? It does appear to be. So there you go. How crazy is that? And then this, I've just done a watch. I'm going to put a video out on one of my many YouTube channels where the winding ratchet wheel has been soldered onto the back of the cone. These are sometimes screwed, and the screws have got points on them. They screw into blind holes, but normally they're like this, and they just fit on. And when you put them on the other way, the holes are normally sort of asymmetric enough that they won't fit round the wrong way. As you can see, if you assembled it like that, you're going to have a problem. So all that stuff off there. And we've got this rat's nest in here of horrible line, really skanky stuff. So different pair of cutters again. We will get the spring out of the barrel, don't worry. That's what you're here for. Could we have the person mix up the screws also change the line from gut to steel to improve it? Yeah, who knows? I mean, we can spend our life conjecturing what people did or didn't do. But I think you're right about the line. I was probably sounding really mean about it just because I'm like, you know, had enough of seeing those things. But of course, it's, what's the word? A form of logic that if you put a wire rope on, it's like a machine. It's like one of those cranes that you see down the docks, those derricks, those cranes you see down the docks. And so it makes sense that that is an improvement. Who said that? Oh, Jeremy. Well done, Jeremy. You're right. I think the kind of mentality is that we're improving, not here to improve the thing. If you want to improve the clock, make a new one. Okay, so with the knot here, if you put a gut line in, let me just arm myself with a bit of scrap gut line. Just be careful when you thread it through, because the edge of the hole can be really sharp and it can actually damage the line. Now this one is a bit chunky, so I'm not doing this particularly neatly, but you'll pull the line through. This has been already tied for a demo. I'm just going to tie a regular knot in there, but it would probably be better to do a figure of 8 knot, give it a bit more size. Sometimes there isn't a whole lot of space there inside this recess, and you've got to kind of punch the knot down with a piece of wood to get it to sit there, because what you don't want, because you saw that ratchet wheel wasn't screwed on, you don't want it pushing the ratchet off. It can interfere with the winding. So this knot has to be quite compact. So I'll take my gloves off because we're going to get the vice out here. So like on a long case clock, I made a video about it. It's on the YouTube channel. When you do the knot, pull it tight, get a pair of smooth jawed pliers, pull it really tight, and then don't cut the line, break it by burning. And with this natural gut, what that does is it causes the fibers to contract. So when the knot is finished, there's a nice kind of bulbous bit here, which helps it not pull through. Toptip.com. I might have made that not too big. Let's have a look. Yes, I have. Yeah, so it just wants to be a simple, you know, just like a single knot here. I don't know what to call that kind of knot. I'm sure we've got plenty Boy Scouts out there. We don't use the US word in this place. Do you clean the Fusee ultrasonically? No, no ultrasonic cleaning. Mix with the screws. Oh, we don't use the US word in this place. I don't know what that means, Jonas. Sorry. Have I said something that's off-piste? Apologize if I have. Anyway, it wants to be a smaller knot, then you can punch it down inside the hole, and that will not pull through. It will not pull through. Oh, ultrasonic. Yeah. No ultrasonic cleaning. Totally unnecessary. I think people say it speeds things up, which it may do if you've got those relatively modern, complicated clocks and you're doing, oh gosh, what's happening there? Lots and lots and lots. Oh, my keyboard's under there, that's why. But no, I don't use one. I don't find any need for it. I actually like the mechanical cleaning element because, again, it forces you to really look at the components. And here, there just aren't many components. What are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like 22 dozen components in the clock. Just doesn't take long to clean it. So I prefer to clean it manually with a brush. It's in my book. Right, okay. So let's pop off our barrel cover. Don't whack it on the bench, please. I won't go on because I've gone on quite a lot tonight, so I apologize. Maybe it's the heat. Don't whack clocks, just like go at it as gently as you can. We've had a big run in with people saying, smash the barrel down on the bench. These barrels are not from solid. No, they're not. Look, it's fabricated. You don't want to begin to break these soft soldered joints. You can use one of my patented barrel cap removing devices. There we go. It's easy, more controlled. Get the barrel arbor out. There's our barrel arbor. Always give it a sniff. Remind you of a sort of a old church kind of smell. So cool, nice. These barrel arbors often gall. There's micro cold welding. Not on this one, actually. This is in really good condition, but often you'll see that on the pivot. Okay. You'll notice the difference between one of the few differences between a chain-driven fusee and a line-driven fusee is on the chain-driven fusee, the barrel has just got one little slot where the chain hooks in. We'll look at one of those maybe next week. I've got one waiting in the wings. A line fusee has got 3 holes drilled in the edge of the barrel, if you can see that. So the line goes in through the first hole, it goes out through the second hole, it goes back in through the third hole, and then it traps underneath the inner loop there with the end facing inwards. So when you wind the clock, the end of the line, as it's done here, actually, this is a really good example. Can you see that? Got trapped under the mainspring there, can't do any trouble. If you have it going the other way, so the line's facing out, I've seen it where it makes its way out of a cutout in the barrel cap and rubs on the inside of the plate. So I think I see solder here. Let's just have a look. Might just cut it off. Just to expedite things. Looks like quite an old spring. So yeah, in through the first, out through the second, back in through the third, and then tuck it under the loop. So that's got rid of that. You can see the 3 holes there better now. Yeah. For clocks, I think again in this kind of sense of improvement in the Victorian period, a lot of clocks were updated to chain. So they have both. They have 3 holes but a chain, and the fusee was recut to from a round or semicircular section to a square section. So we've talked a lot about winding mainsprings. My advice is to use a mainspring winder with concentric tubes like the Bergeon type or the Ollie Baker type. I don't know anything about the Ollie Baker ones. I use the kind of old-fashioned type of mainspring winder, which again we should talk about in our book, but not ideal for beginners, and especially not with a reasonably chunky spring like this. So I'm just going to, because I've only got 5 minutes, rearrange my camera. In fact, let me just have a... Right. Okay, let's just do a quick camera rearrangement. We are rather inelegant, I'm afraid, but seems to have worked. And is it in focus? Yeah, pretty much. Okay, so yeah, mainspring winders. There's loads and loads and loads of reviews on YouTube about the Ollie Baker type mainspring winder. As I say, I don't advocate this type for the beginner. In fact, what I suggest when you're actually beginning, can simple non-fusers be removed and installed by hand without a winder? No, not really, Devashish. They can't, unfortunately. It's dangerous to remove them by hand, and it tends to distort them. Now, it's not the end of the world if they get distorted. People, again, you know, disaster scenario. But I would say no. If you haven't got a mainspring winder, just leave the mainspring in the barrel unless it's actively rusted. I made a video on it again. Take the barrel cap off, take the barrel arbor out, clean the bearings, add a little bit of lubrication as a kind of what's the word? A confidence building exercise to get your first spring done. But actually, as part of practice, if you're going to repair many clocks, then you need to buy a mainspring winder, I would say anyway. So as always with springs, rather attractive safety glasses on. Let's just check that's super tight. Got my safety jacket on. Got my safety gloves on. Just wind power onto the spring. Good. Got myself a bit of thick-ish cloth and my special pliers that I'd gotten ready for the job. There they are, hiding under the clipboard. So let's just get the hooking facing us. Grab the badger. Yeah, so it's not the original spring for the clock by the look of it. It's later. I did think that this clock was really quite heavily driven when I first looked at it. So let's just get the unhook it from the arbor. There we are. Camera can move back. Gosh, what's that? Some information about my computer. Anyway. Yeah, one of the many projects that I've got lined up is to design a mainspring winder and design a depthing and make a depthing tool as well. But gosh, so many projects. Anyway, there's our spring. Remember, springs are very susceptible to rusting, so wear gloves. These are a bit thin actually, but they'll do. So yeah, I mean, it's difficult to tell, but the originals, those Victorian springs, they've often got round holes in the outer end, and they're quite textured. They're quite rough, sort of drawn texture. I think, of course, I don't know, that this spring is quite smooth, and it's. I would say I don't know. It's not my specialist field, but I would say this was mid 20th century, something like that. And nothing wrong with the spring other than it's really strong. You know, when you wind the clock, it feels strong. So the question after all that is, what do you do if you want to reduce the power of a spring in a Fusee clock to make the clock pinions and wheels and pivots last longer? Well, there's a few things you can do. You can obviously try and get a thinner spring, which is really difficult, or you can fit a narrower spring, which I know, again, this will sound like the clock by putting sort of heresy. You can get a narrower spring and then make up the gap in the barrel with some loose fitting sort of like thick washers or discs of brass, or even engineering plastic. I've done it before with nylon, works really well. If you can't get a spring like this, let's just have a look at how thick this is. Let's try and straighten out. So it's about 0.38, 0.4. If you can see that on the camera. Yeah, just about. It's about 0.38. It's about 0.38. So I mean, a difficult decision as to whether you put the clock back with this spring in. I think what would be really useful, and I'm sort of so many projects on at the moment, but is to get one of those torque screwdrivers and just see how much torque is coming out of this spring. And I don't know, Debashish, the thing about why people replace springs, it's one of the, for me, and I know it's an unpopular view, but it's one of the biggest causes of the degradation of antique clocks there is going. If you replace springs, replace them with thinner ones, because the spring like this is later and overdriving the clock, absolutely. But this idea about the spring being set when it's 2 or 3 times the diameter of the barrel, I just don't buy that one bit. Try it first and see what happens. I've no idea. I'm afraid you would have to ask those people what their justification is. And they might say something like, I don't know, obviously I'm not their spokesperson, but oh, you've got to replace the spring because if it breaks, then there'll be this disaster scenario. Yeah, springs do break. I'm not saying they don't. Anyway, I hope that's been stimulating. I know some people will disagree about the whole spring set thing. No idea where that came from. This spring, we probably will never know. It needs somebody to do some research. I think one of my students, Mostyn Gale, who we sometimes see here from California, is working on researching springs and the metallurgy. Really interesting project. But if I can get round to it, I'll probably buy one of those torque screwdriver things, torque gauge effectively, see what the torque output of this spring is, and see how much the clock will run on. Much longer term project. We're out of time for now. Hope that was of use. I'll get this all cleaned up and we can pop it back together for next week, because will you replace this spring? I don't know. I mean, as I said, Sam, when I first wound the clock, I thought, oh, gosh, this is like when you wind a Fusee clock with an earlier or original spring of the right strength, you think, gosh, this is so easy to wind. There's quite a lot of wear on these pinions. We saw that pivot that's worn. Is this spring contributing to that? I think before I commit to replacing it or not, I need to find out how much the clock will run on and how much torque this spring is putting out. And if they're within 10, 20, even 30% of one another, but I bet you this clock will run on half the value of this spring, if not significantly less. But let's find out. It'll take a long time, data. Yeah, let's try it. Good. Well, I'm glad you're up for it. Next week, beginners, please don't lose heart if this all looks a bit crazy. Next week, we'll look at the same thing, but chain-driven Fusee. And that should be same kind of adventure, but we'll just look at a Fusee chain, how you handle that, how you clean it, and so on. So apologies. Apologies for anybody who has been put off or whose values. I always say on the Facebook group, there's no right or wrong way to repair a clock, but there are certain things like the replacement of the spring, like the use of the kind of universal use of ultrasonics for cleaning, that I personally feel I do have to kind of push back a little bit on. So I hope we all take it in the way that it was intended. See you on Facebook. See you on Thursday for the live stream. And if not, have a great weekend and we will see you next week, all being well. So thank you very much. Bye for now. Lots on the live chat. So I'll catch up over the weekend with that. Thank you.